Hey everyone, it's Justin again. We've spent a lot of time talking about how to interpret the slope and intercepts in a graph. So now it's time to actually use that knowledge. We're about to solve problems where the answer is hidden in the graph. All right, first up. Erica walks home along a trail. The graph below shows her distance from home as she walks. How far can Erica walk in an hour? First, let's take a look at our axes. The y-axis is Erica's distance from home, measured in miles. And the x-axis is how long she's been walking, measured in hours. To answer the question, we need to find how many miles she walks per hour. Ooh, that's a unit rate. And unit rates take the same form as the slope. This will be easy now. From this point at 1,6 to this point at 2,4, the rise is -2, and the run is 1. So the slope is -2 miles per hour. Be careful though, she isn't walking -2 miles per hour. Her distance from home decreases by 2 every hour. So to answer the question, how fast is she actually walking? Well, in an hour, Erica walks 2 miles closer to home. Let's use the same graph to answer a different question. How many hours would it take Erica to walk 5 miles? What we're really trying to do here is convert 5 miles into some number of hours, but how? We don't have a conversion rate. Or do we? We already figured out that Erica walks 2 miles every hour. We can use that as a conversion rate. 2 miles equals 1 hour. Now we just need a little dimensional analysis. We start with 5 miles and need to convert that into hours. So to get rid of the miles, that part of the conversion rate needs to be on the bottom with hours on top. And voila! We get 5 divided by 2, or 2.5 hours. This makes sense because if Erica walks 2 miles every hour, then in 2 hours she'll walk 4 miles, and in another half hour she'll go another for a total of 5 miles in 2.5 hours. All right, next problem. Jose is selling ice cream bars. How many ice cream bars does he have to sell to break even? So what does break even mean again? It means the profit and losses balance out. In other words, we want to find where Jose neither makes nor loses money. So what would we call that point? The break-even point is the x-intercept, because after selling some amount of ice cream bars, Jose will have made back the money he spent to get them. So where is the x-intercept on the graph? Right here at 11,0. So if Jose sells 11 bars, he won't have any losses or profit. He will have made $0. All right, next up. It hasn't rained in a while, and the river is drying up. How high was the river when it last rained? Okay, how are we supposed to know the height of a river when it rained? This graph only shows what's happened after the last rain. Wait a second, look at where the x-axis starts. 0 days since the last rain would be the moment it stopped raining. So if we find the water level at that time, we'll be able to answer the question. According to the graph, it looks like the water level was at 19 feet when it stopped raining. So 19 feet is the answer. In the next and final lesson of this unit, we'll be flipping it around. Instead of finding values from graphs that can help us solve problems, we'll be using the values given in word problems to begin making our own graphs. I hope you got some graph paper handy. Hey, hey.